Okay, let's get into systems of equations. There we go. So the first thing we're going to talk about is testing solutions. And I believe we've seen this already with a single equation, and if we haven't, the process is exactly the same for a single equation. If we're given a solution, in order to check that it works, we need to check that it works in both equations. That being said, if it doesn't work for one, it doesn't really matter what happens on the second equation, and we can stop. But if we want to see if it works, it has to work for both of them. And so that point represents an x and a y. So my x is -3, my y is 4. So I plug it into the first equation, and I want to check to see if the left side is equal to the right side. Well, it just so happens 5 times -3 gets me -15. 2 times 4 gets me 8. If I add them together, I get -7 is equal to -7. So I now know so far that maybe my equation works. It definitely isn't going to fail on the first step, so I'm going to keep going and plug it into the second equation. So plug in -3 for x, 4 for y, multiply 4 times -3 to get 12, add them together, and I find that -8 is equal to -1, which is not true. So when it's not true, we say that it is not a solution. Now, there are two methods we're going to look into for solving a system of equations with two equations. The first is substitution, and honestly, this is the one that I see the most because it follows the same procedure every time. The second one is elimination. We'll see it. It kind of has, you have to put a little bit of thought towards the beginning on how to set it up, but we'll see that. So with substitution, the goal is to solve for one variable, and then once you have that one variable, substitute whatever you found into the other equation. So in this example, that's actually nicely done for us. I have x already solved for. What I do then is I take that x, I plug it into the first equation, and then I just go ahead and solve for my y. So 2 times 4 gets me 8, 2 times y gets me 2y. I would add the 2y's together, or the 2y and 3y together to get 5y, subtract over the 8 to get -10, and then I divide by 5 to get -2. Now, when we're solving systems of equations like this, there are two things we need to solve for. We need to solve for an x and then solve for a y. So we did solve for a y, but now we need to take that result and find out what our x is. And we do that by picking either equation. Usually one is better than the other or easier to solve than the other, but both would work. I chose to plug it into the second equation. Nope, I chose to plug it into the first equation, even though the second equation would have been easier. So I'm plugging it into the first equation. To solve for x, I replace my y with -2. 3 times -2 is -6. Add the 6 over, divide by 2, and get x is equal to 2. And y is equal to -2. Now, since we're dealing with an x and a y, it's a good idea to write our solution as a point. And if I wanted to check my answer, I would do the exact same process that we saw on the last slide of plugging in my values and seeing if they work for both solutions. And let's see one more example. In this case, I don't have a variable solved for. I have my x's and y's on the same side for both of them. So my first goal is to isolate one of those variables. I'm going to isolate something on the second equation. Okay, my y. I'm going to solve for my y. That being said, you could solve for your x. Your process might look a little bit different, but you should get the same result as me. So I solve for y by subtracting x from both sides. Y is equal to 4 minus x. And then from here on out, it's really much the same from the last example. I plug in the y into my first equation. I solve. 2x minus x gets me a single x. I subtract 4 over, I have solved for x. Now, something that's worth mentioning, that if I plug in the y is equal to 4 minus x into the second equation, I kind of run into a wall. So anytime you're doing substitution, if you solve for your variables in one equation, you plug that into the other equation. And by a wall, I mean you can kind of check it yourself. If you plug your y into your second equation, you're just going to get 4 is equal to 4, which is absolutely true, but doesn't really help you your problem-solving process. And then again, very similar to last example, I'm going to plug in my x is equal to -6 into either equations. And in this case, I chose the first one. And again, I probably should have chosen the second one because in my mind, that's an easier solve, but whatever, either one works. So I plug in x into my x in my first equation. So 2 times -6 gets me -12. And then I add the 12 over and I find y is equal to 10. And then to write it as a point, I get -6, 10. I don't know why I picked the hard thing to do when I was making these slides. Okay, so I made an error, so we know eventually we're going to get to y is equal to -3, but let's figure out how to get here. Okay, solving by elimination. So substitution makes sense as far as the word choice goes. You solve for a variable, you substitute it into another equation, and then you solve. And same type of logic with solving with elimination. What we're going to do is, instead of substituting, we are going to get rid of a variable. We're going to eliminate it. And so in this case, in order to eliminate the x, what we do is we just add the two equations. And so this is kind of an oversimplified case, and we'll see a better example next time, but that's kind of the goal. Our next slide. So if I add my two equations, we'll see, okay, 2x minus 2x is 0. And so -4y plus y gets me -3y, and -10 plus 1 gets me -9. You'll notice my signs kind of shifted slightly because I fixed this slide. So now I divide both sides by -3, I get y is equal to 3. Now what I do with that is I take my y result, I plug it into either equation, and then solve for the other variable. So from here on out, it's the exact same process of substitution. So I plug in my 3, I would subtract the 3 over to get -2, divide both sides by -2, I get 1. And then to write it as a point, it would be 1. And then to write my answer as a point, just do 1, 3. Okay, now we are going to see a little bit more of a complex example. And this is a good way to show that sometimes elimination is a little bit more tricky on the front end, but it's kind of less work on the back end. And so I have an equation here, and now I can't just really add the two immediately. I mean, I can, but I'm not going to really achieve a whole lot. I'll have 8x minus 6y. And so I'll have a single equation with two variables, or kind of the whole goal of this entire section is to make it so that we have one equation, one variable. So with that goal in mind, we think, okay, I'm choosing to eliminate x. Again, you could, or I'm choosing to eliminate y. You could choose to eliminate x, and the process will look similar, other than like the numbers might be shuffled slightly. And so if I'm trying to isolate x by eliminating y, I look at kind of the things in front of my y's in both equations. And that gives me some information on how to eliminate my y. Specifically, what I'm going to do is I'm going to take the bottom equation's coefficient, that -3, and I'm going to multiply the top by -3. So the entire equation I'm going to multiply by -3. And now on the bottom, I'm going to multiply -2. I'm actually going to multiply by +2. So when you multiply the bottom equation, you're going to have to flip the sign of the coefficient. Because if you don't do that, again, you're not really going to eliminate that y. So again, kind of to go back through it one more time, I take the coefficient of my y on the bottom, multiply my entire equation on the top by that value, take the coefficient of the y value on my top equation, and multiply my bottom equation by that value with the sign switch. So if that was a +2, you do -2. It's a -2, so we're going to multiply by a +2. So yeah, there's that idea of flipping the sign. And now once we've done that, I get 3x times -3 gets me -9x. -2 times -3 gets me +6y. And then 6 times -3 gets me -18. On the bottom, 2 times 5x gets me 10x. 2 times -3y gets me -6y. And 2 times 9 gets me 18. So again, I'm multiplying every single value by that value that I put on in red on the outside. And so if you did the wrong sign, what's going to happen in this step is when you add things, things aren't going to be eliminated. So in this case, what happens if we add our two equations, we find that negative 9x plus 10x gets me a single x. My y's go away. My 18s go away. So really all I'm left with is a single x on the left side, y's are gone, and 0 on the right side. So I don't really have to do any solving beyond that, which is kind of the nice thing with elimination. Usually solving after that elimination step is either no steps or maybe one step. So it's a little bit hard up front. It gets a little bit easier after you do that. And then you may have guessed it, exact same process for substitution. I plug in my x into either equation. I pick the first one. So then I get 3 times 0 is 0, leaving me with negative 2y is equal to 6. Divide both sides by negative 2. Y is equal to negative 3. And then I have to write it as a point. And that's it for this section.